We're now going to take a look at part B of example 1 in section 17.1 on parameterized curves. So for part B, we're again given the maps of the coordinates x, y, and z for a parameterized curve. So notice we do have now 3 coordinates, so this curve is going to live in 3 space, but we can observe that the y coordinate is just a fixed y equals 1. So if we were to draw this in 2 dimensions, we could draw the x and the x and the z axis rather, and just draw the projection of this curve in the xz plane to give us a sense of what this curve looks like. So let's go ahead and do that first. So I'm just going to draw this out. We've already had some practice using tables. So I'm just going to draw out what our curve is going to look like if we fix y as 1 and look at x and z. So here we have x is equal to 2 cosine t, y is equal to 2 sine t. So again, we have a similar form of our x and y coordinates as we did in example 1 part A, where the cosine or the x is taking on cosine values, y is taking on sine values. So we think that we probably will also get a circle here. Let's just compute a couple values to make sure that we are, in fact, on the right track. So when t equals 0, well, cosine of 0 is 1. So x will be 2. Sine of 0 is 0, so y will be 0. So we should have the point 2, 0 when t is 0. And let's just check when t is pi over 2. When t is pi over 2, cosine of pi over 2 is 0, so we get 0 in the x. Sine of pi over 2 is 1, so we get 2 in the y. So we have 0, and rather not y, this is z. Let's remember. It's common to get in the habit of always calling the second coordinate y, but here it is z. So we could do this a little bit more, but we see that we start with this point here, and then we go up to this point here. So our curve, we could test this for the other values. But our curve will look like this circle centered at x equals 0, z equals 0, and radius 2. Okay, so now that is when y equals 1. And in fact, y equals 1 for the entire curve. So what we might want to do, though, is plot this curve in 3 dimensions. So now in 3 space, we're going to have our 3 axes. So x, or rather we'll do x here, y here, and z up here. So we know that y is always going to be at 1. So our curve is going to occur in this plane where y is 1. And so we can kind of visualize that plane that we just sketched. So here's the z-axis, here's the x-axis, and what we just drew was a circle with radius 2 in here. So if we wanted to see just the image of our circle, well, it would be centered at this point here. It would be located in that xz plane that's parallel to, or rather that's 1 distance away in the y direction. See if I can do a circle here. There we go. With radius 2. And we can even see so that the orientation rather of this curve, well, it starts in the positive x and then moves towards the positive z. So we'd start here in the positive x, then we'd move up to the positive z direction, and then we transverse our circle like this. So here is what our curve actually looks like in 3 space. To describe this curve, well, we can describe it as a circle. So we'd say this is a circle with what radius? With radius 2. And now what is this point? What is the circle centered about? Or what point is the circle centered? Well, it's centered at this point here, which is the point 0 in the x, 1 in the y, 0 in the z. So it's centered at 0, 1, 0. And then we can also describe its orientation. And how we can do that is, well, if we view this circle from the positive y direction, we look down at it from the positive y direction, we see that it's going clockwise. So then we can also say that this curve, because it's parametrized, we traverse it, or we draw it a certain way based on how t changes. So we can say it's oriented clockwise when viewed from the positive y-axis. So now we've not only drawn our curve with its orientation, but we've described it in words as well. Awesome. Great job watching through this video.